Hi students, and we're going to take a look at further problems involving right triangles. So here's a problem for us. I've got two buildings, the corporate headquarters of Acme and the corporate headquarters of eBay. And I want to know what the height of two buildings are, but the only measurement I've taken is I know that the buildings are 70 meters apart. So it's possible using trigonometry in order to find out the height of these two buildings. Now first, we're going to have to put somebody at the very corner of the roof of eBay here, looking at the very corner of Acme and at the very base of Acme. So let's see what that looks like. So this is their line of sight, and we're going to take a look at what exactly they're seeing. So we're going to measure this angle here and this angle here. So we're going to find that this is 22 degrees. And this is going to be 18 degrees here. Now, this angle is known as an angle of elevation because it's rising from the horizon. And this angle here, the 18-degree angle, is known as an angle of depression because it's being lowered from the horizon. So if it's increasing from the horizon or coming up from the horizon, angle of elevation, coming down from the horizon or horizontal line, it's known as the angle of depression. So the other thing that we have to look at here is this line straight across. This is looking at the Acme building right at 90 degrees. So if it's hitting it both at 90 degrees, well, what kind of shape have we just made? What we actually have are two right-angled triangles. And these are what we're going to use in order to find out what the height of Acme and eBay are. So to start us off, one thing to keep in mind here is this middle line here, this horizontal line, is the exact same length as this horizontal line. They're parallel. So this length here is also 70. So we're going to bring some color into this. And let's take a look at, with respect to this first triangle, so I'm going to call this triangle 1. So with respect to this first triangle, let's label some of our sides. Well, this is the opposite side. This is the adjacent. And this is our hypotenuse. And for what we're going to call triangle number 2, here we have this side is our opposite. This side is our hypotenuse. And this side is our adjacent. So what we have is enough information now to solve for the height of Acme and the height of eBay. Notice that the height of eBay is the same as the opposite side length of triangle 2, and the height of Acme is the opposite side length of triangle 1 plus the opposite side length of triangle 2. So I want you to pause the video here and use your trigonometric skills to first find the opposite side length of triangle 2 and then the opposite side length of triangle 1. So we're going to have to use SOHCAHTOA to help us out. So let's see. We know the adjacent side, and we're looking for the opposite side. So that means that we're needing to use tangent. So let's set up our equation here. So here's what we find. The tan of 18 is equal to the opposite side divided by 70 meters. And what we're going to find then is, using our algebra skills from lesson 2, that the opposite side is equal to 70 times the tan of 18. So now, let's find out what opposite is approximately to the nearest decimal. So what I want you to do now is I want you to solve for triangle number 1 for its opposite side using the same process. So let's take a look at our solution. Here we're looking for the opposite side of triangle with the angle of 22. So the tan of 22 is equal to the opposite side divided by 70 meters. We find then that using our algebra trick that 70 meters times the tan of 22 is equal to the opposite side. So rounding to the nearest decimal, the opposite side is equal to 28.3 meters. So now that we know the two different opposite sides, let's find our final solution. Well, eBay's height is equal to 22.7 meters, and Acme's height is the combination of the two opposite sides, which equals 51 meters in total.